Hi and welcome to BYJU'S 12th board preparation series. Today our topic of discussion is nuclear physics, then we have semiconductors, and then we have communication system. Alright. Now let me tell this in advance that this is a very short session and this is not about actually learning those things. I'm not going to teach the topics themselves. What I'm going to discuss is what are the relative importance of different topics in these chapters, and perhaps in what manner should you prepare a particular topic, and in what manner should you present a particular topic in your board exams, right? Now, in every session which I do on board exams, there is one thing which I keep attach, like you draw a diagram and label it properly, okay? And for that reason, always leave some spaces after your answers and use those spaces later to fill it with diagrams and examples. Now, having said that, let us start with nuclear physics. Nuclear physics has basically these two parts. There's a theoretical part and then there is a numerical part. The numerical part comes basically in the radioactivity. Now, in the theoretical part, you learn concepts of what is binding energy, what is nuclear force, what is binding energy per nucleon, why is binding energy per nucleon more important than binding energy itself, how to find the Q value of a nucleus, what makes a nucleus more stable, a particular nucleus more stable than other nucleus, right? And then three elements in that curve, I would say nuclei in that curve must be there in your memory, one in the beginning, one in the top, one in the end. Be very clear what is it that we represent on the x-axis, right? Is it atomic mass or is it atomic number? Because students do that mistake, they overlook if they have not prepared the chapter very well when it was actually being taught, and in the end when they are rushing through it, they don't they are not very meticulous in like noticing that the x-axis is like mass number and not the atomic number and all that, right? So so that graph is very important, right? That is one of the most important things from the first part. Then you can expect a 1 marker or two marker question on finding the Q value, explaining why binding energy per nucleon is more important than binding energy itself, and so yeah, basically that. And maybe you can expect a 3 marker question on nuclear fission and fusion, right? What is nuclear fission? Supplied with an example. What happens in a nuclear fission? Does the energy is released? Is the energy absorbed? Why is the energy released? And what is that basic principle which nuclear disintegration follows? The E is equal to mc square law, right? So those kind of questions you can expect from nuclear physics. Although the topic itself doesn't have that great a weightage, but because it's not a very difficult topic, right? So you can always score marks whenever the questions from nuclear physics are asked. Now, from the other part, the radioactive part, you have basically numericals that you can get, and you can get to fill in or to supply with the radioactive reactions. So when you get these numericals, the core of this numerical is the radioactive decay. You remember it's a first order decay. The equation n equals to n naught e to the power of minus lambda t, that equation is very important, right? What is lambda there? That is the decay constant. What is the definition of decay constant? Does the decay constant of a nuclear reaction change with time? What is half-life? Why is the lifetime of a nuclear reaction infinity, and why can we define a half-life? And how is half-life related to lambda? You can get derivations on that. What is the relation between lambda and half-life, or derive the half-life? What is mean life? What is the definition of mean life, and how is it different from half-life? So these kind of questions can be asked in 1 marker, 2 marker. A derivation can be asked for 3 marks as well. So these are the kind of questions you can expect from this chapter. Then regarding reactions, they can ask that there is this particular nuclei and it undergoes 2 alpha decays and 1 beta decay and 1 gamma decay, and then what nuclei does it turn into, right? So those kind of questions. What happens when an alpha decay happens? What happens when a beta decay happens? How do you in the first place you need to know how do you represent a nuclei? What is the number which is written on the top? What is the number which is written on the bottom, right? You have to be very clear with what these are. If you're not, then you'd not be able to understand the reaction problems, and if you don't understand the reaction problems, that is not a good thing, because they are very easy. There's nothing much in them. Alpha decay happens in this much, by this much the atomic number changes, by this much the atomic mass changes. So there's nothing rocket science into that. Like, so you have to be clear with certain basic things, and that's basically nuclear physics for us. Okay. Then if I talk about semiconductors, now semiconductors, you start with the difference between intrinsic and extrinsic semiconductors. What are intrinsic semiconductors? First of all, what semiconductors in general? Then there is a P type of semiconductor, and there is N type of semiconductor. So from this section, you can expect a 3 marker or a 2 marker on the difference between intrinsic and extrinsic semiconductor, the difference between P type and N type electron jump from the conduction band to valence band, and what happens. And in metals, what is the difference between the conduction band and valence band, and what is the difference between semiconductors, and what is that number of that gap. And then what happens in case of insulators, that it does not conduct, the explanation from the energy band theorem. Okay, and from where does the band themselves arise? How does the energy levels they mix up together and all that. So this can be also a long question, and energy band diagram has to be supplied with a diagram, very simple diagram where the bands are either overlapping or not overlapping. So these questions you can expect from here. And basically what I'm saying is, from the first part, a comparison question, and then an energy band question. Then you can expect questions from p-n junction diode, which is a very important topic here. Like, what is a p-n junction diode? How does a p-n junction diode work? What is the different kinds of current that you have there? What is diffusion current? And what is a total? What is the voltage gap that you get, right? Why do you get that? Why is this potential barrier that gets created when a p and an n junction meet together? What properties does it give rise to? What is a diode? So these kind of questions can be asked as 2 marker and 3 marker, but maybe not like for a 4 mark question or a 6 mark question. But you can expect questions from here. See, the point in boards is, I cannot definitely say that whether this topic is important or this topic is not important. I can say relatively, yeah, that I've seen that this topic has been asked a lot, and this topic has not been asked a lot. So but we can only talk in probabilities. You understand that. So the point is that if you're preparing for boards, I would say that don't skip anything. Okay, read almost everything, because it is not that your aim should not be to get like 60% or 70% marks. You should study everything, and you try to score as much as possible, because this is not extremely difficult thing to do, right? Then you can get simple 1 mark, 2 mark question on explaining what do you mean by forward bias, what do you mean by reverse bias, and what is the condition of the p-n junction and in reverse and forward bias. Then there's this topic of rectifiers. You can get a question on how p-n junction can work as a rectifier. What do you mean by a rectifier? Then you have to supply it with diagram. There are also some derivations on how does it change the waveforms, those kind of questions. So in such questions, always draw the waveform. Don't skip that, because of course diagrams important. Then you can also get questions on Zener diode working as a voltage regulator. So that is also a possible 3 mark question. And then comes transistors. So the problem with transistors, in fact the whole problem with this chapter, I'll tell you, is this: it is a very volatile chapter of physics. Now, I have taught this chapter many times, I have learned this chapter many times, but because I'm not into transistors in my day-to-day life, and I don't encounter these things, and I don't think about them a lot, they just vanish from my memory. It's too much memory in this chapter. There are too many logical jumps that happens in this chapter. So the problem with this chapter is that I cannot expect to read this chapter sometime, and then after like many days, someone would ask me some questions, and I would like be able to answer that question immediately. So that is kind of difficult. So I would suggest that topic of semiconductors and topic of communication system must be kept for the end, because not to end, like not very late, but like kind of towards the end, because this idea has to be fresh in your mind. Like in a transistor, what is a common emitter transistor, what is a common base transistor, and this is what happens, where do you put the load, where you don't put the load, what is it that is happening if you how would you find the resistance and all these things. Okay, you can also expect questions from what do you mean by electrical resistivity of semiconductors, and voltage characteristics of Zener diode. That's an important question. Voltage characteristics of Zener diode can be asked as a 4 marker also, where you have to supply it with that graph that you have. Okay, and you have to explain what different parts of that graph means, and what do we mean when we see they ask you question where there's like a bunch of gates. Okay, and a combination of gates, and then they would feed in 0 or 1 from one end, and you have to figure out what is the answer. So you have to like take that signal to each gate and see whether the signal changes or not. So for each logic gate, what is the truth table, what does it do to a signal, that has to be very clear in your mind. In fact, you should write it down somewhere, and always for logic gates, always use the diagram to solve the problem. Okay, always go through the diagram, and don't be like, I mean, like I don't think there is any other way. Like there's diagram in front of you, you see what happens when I go through this this part of the gate, what happens when I go through this part of the, what is the final answer, and always cross check. But it's easy because it doesn't take a lot of time. It's kind of also fun, and it's scoring. So please don't skip logic gates. Logic gates are important, and they are also fun. So that is about semiconductors. Then the next topic that we have is communication system. Now communication system is a very small topic. If it were for JEE, I would have said that do this topic maybe like a day before your exam, if you have some time for an hour or so, because very few questions are asked in JEE itself. But for boards, you can expect a question from communication system. So my best suggestion for communication system would be for you to read NCERT once. More than that, nothing is required. Okay, go through NCERT once. Take care of what certain things that you need, like what are the elements of communication system, and how would you represent it using a block diagram, which is a child's play. It's very easy to draw those block diagrams, but if you don't know, then you're seriously losing marks. Okay, and if it is asked as an optional, that's fine, but if it is not, then you lose marks for something which is so, like, you know, silly and simple. So go through that topic, don't leave it. I mean, please don't leave it. Elements of communication system is what I was saying, the block diagrams. What are the basic terminologies that are involved? What is a receiver? What is a transmitter? What do we mean by noise? What do we mean by medium? So these kind of questions can be asked as a 1 marker, 2 marker kind of questions. And how does the propagation of EM waves happen through in all these channels, like from where to where it goes, and where to where it goes, and all that. Now another important part which is there in communication systems is modulation, right? So you have to be very clear with what is modulation. You have to be clear with what is frequency modulation, what is amplitude modulation, what are different types of modulation, and what is modulation index. So these kind of questions you can expect from this chapter, but overall the chapter is not like greatly important, but in fact nothing in boards should be a skippable topic, right? So that's what about nuclear physics, semiconductors, and elements of and communication system. In nuclear physics, remember that the theoretical part would fetch you'll have to write answers, but there is this numerical part also, which is very easy. For semiconductors, remember that it's a volatile topic, so keep it to the end, or at least revise it 2 or 3 times, or at least once before your examination. And elements of communication system is very easy, so if it comes and if you're not writing it, then you are losing very easily available marks, right? So I'll take some questions now. Garv Lalwani is asking, sir, please do some of the live sessions for class 10 students, because they're also going to give board exam this year. Please, sir, please. Oh, all right. So we'll try to do the live sessions for 10th boards as well. I will update you on that. Is photocell important? Yes, photocell is an important topic, but not a very important topic. But like there's nothing much in it, so you just read through it once. Maybe see how the diagram is made. You don't have to make a precise diagram. How do you use transistor as a switch? Now this is a question that will require some discussion, and the session is not about that. So I need to get into transistor and how does it work and how can you use it as a switch and all that. I would suggest you in this point that to download our app, because we have covered all these things beautifully, and the point of living in the 21st century is that everything has to be upgraded. So when you have an app, anytime you're sitting in your room, you can go back and read this concept on your own discretion. You don't have to wait for a teacher to come and teach you, right? Whenever you feel like, in the middle of the night, you feel like you can watch those videos. Okay, you can watch it at any rate. You can watch some part and think about it as long as you want. You can go talk to any of your teachers or any of your friends. So that's the whole point. So this would be the end of this session. I hope this was useful. I request you, I would say that I suggest you, and it's a request because it might be helpful to you, so there's no point not requesting and all that, leave it. But what I'm saying is, go to our YouTube channel. There you'd find really interesting videos there, and you would understand what we are trying to do. We are trying to create engagement towards different topics, and do download our app and be updated with the activities which happen here, because we keep these live sessions again and again, so that you're thorough with what is currently going on in the subjects. All right, with that, thank you.